Namaste. Myself SSPM Sharma, working as an assistant professor in Department of Electrical Engineering at Mewari University, Rajasthan. Today, I am here to deliver a lecture on temperature measurement systems. So, going into the slide, the temperature measurement systems. What the student is going to get beneficial from this lecture. The instructional objectives of this lecture after the learning process completely done by the students, the student could be able to understand the principles and operations of the various temperature sensors that are existed in the industrial environment. Then after, he can understand the signal conditioning mechanisms that are evolved in the various temperature sensors. The major applications of each and every temperature sensor can be described by the student, and the choice of selection of the sensors for a particular parameter, which sensor is to be selected. These all things are the obtained results after the student is attending this lecture. So basically, going into the temperature measurement systems, the first thing is we require is what is the need of the temperature measurement system. If we are looking at the needs of the temperature measurement system, here I have specified the first thing as a control. So the control process, you can simply take the control mechanisms in a process industries are the major requirement. So simple one example we can give is our reactors, or we can give our heat exchangers as an control elements, because if you are looking at the heat exchangers, the heat exchanger, it consists of two basic elements. The first basic element is it consists of a cold stream, and the second basic element, it consists of a hot steam. So from the cold steam, from the hot steam, the temperature has to be transformed to in a cold steams. For simple example, if we are taking heat exchangers, you take our gas, simple gas stove. You take the burner. The burner is a hot exchanger, and anything if you are keeping on the burners. And if you are lighting up the process, then the burner is going to transform its heat from its hot body stream to the cold body stream, whichever we are going to get the boil. So the temperature we have to calibrate it, and monitoring conditions or supervisory monitoring systems are recently familiar in each and every temperature measurement systems. So in monitoring conditions, we can simply write it as a supervisory controls. Like if you take a simple example of rolling mills, the big rolling mills are there in which the iron bars are is going to pass between the two rolling mills. So if the operator doesn't know what is the exact temperature of that molten bar, then the rolls may be damaged. So there we require the monitoring condition of, or supervisory conditions of a temperature systems. Recent and nowadays the more major important in the industry process is the safety. So each and every temperature measurement system, it should be operated under the safety conditions, and at the same time it should be operated at the energy efficient manner. Which our operating system we are doing, the process which we are taking in the temperature measurement, it should gain a high energy efficiencies. And certain application demands are also there, where we have to take each and every temperature sensor when we are deciding whether to use this temperature sensor for particular application or not. Then we have to specify what is the range of that temperature sensor, or what is the operating range that is there, and how much accuracy that temperature sensor is going to produce, what is the resolution that is going to take place, and whether the temperature sensor is going to create any environmental issues or not. Because the environment is a recent parameter which we have to concern more about, as it is a temperature measurement system. So each and every temperature measurement system, basically they operate at their time constants that are evolved in the system. As it is a time constant, it will be definitely a non-linear system, because of the noises that are created. Sometimes noises may be included in the environment as well as the system itself. So this is the basic need why we have to study these temperature measurement systems. So the second thing is that the types of measurement systems. how many types of measurement systems that are there. If I am going to the types of measurement systems, simple thing, like here I can show you, these are the different types of the measurement systems that are there. One is a contact type measurement system, and another is a non-contact type measurement system. In contact type measurement system, we are having again four categories. One is an expansion thermometers. Generally, these expansion thermometers are not used under the real-time conditions, so we can treat them as an offline temperature measurement systems are the expansion thermometers. These expansion thermometers are again classified into three types. That is bimetallic thermometers, the liquid in gas thermometers, and gas and vapor thermometers, where generally they are not treated in the case of our normal real-time operating systems or real-time measurement process. And the second thing is the thermistors. If you are looking at the thermistors, thermal resistors, they are simply, these are in a semiconductor resistors. You can say they are in a semiconductor resistors, where their variation of the temperature is definitely based on the resistance parameters. Simple, our thermistor, it look like in a simple, it is in a small bead structures. They consist of a positive temperature coefficients and negative temperature coefficients. As they are small, their thermal inertias are very high. They can easily measure the temperatures of a high resistance values. With the smallest change in the temperature, they can easily obtain the highest change in their resistance values. And another type is in a thermocouples. Basically, thermocouple, by the definition, you can see that whenever two dissimilar metals are joined together, then at the junctions, if there is any existence of temperature differences are provided, then in that EMF is going to be generated. That is the basic principle. These thermocouples work on the principle of an Seebeck effect, basically. And the last is that in contact type, the last temperature sensor is a resistance temperature detectors. Generally, these are the again similar to these thermistors only, but these are the metallic resistances. So with the variation of an temperature, the resistance is going to be varied. Another type of temperature sensors is non-contact type. Definitely radiation pyrometers, based on the third process, like based on the heat energies, we are going to identify the temperatures of an systems. So now in this video we are going to firstly see about only the resistance temperature detectors. So basically RTDs are known as a resistance temperature detector. So as I said, based on the variation of the resistance with the temperature, these are going to be identified. The relation is given like this: RT equal to R naught multiplied with 1 plus alpha T plus beta T square, where this T is an final temperature and this R0, it is an initial temperature. Alpha and beta are the thermal coefficients of the materials, where this T actually the difference between the final and the initial temperatures of the existing system. This is the relation, and the materials that are going to use, as it is a metallic resistance, so the metals that are used in this RTD manufacturing processor: platinum, nickel, copper, tungsten. Whenever you are choosing any sensing element, the basic thing you should see is whether it is a linear or non-linear. So according to the practical conditions, every sensing element is a non-linear element only. Very rarely you will get a linear sensing elements. If we are seeing here, the platinum is a metal which is used to manufacture the RTDs. So here I described the environmental properties and its ranges. So the property is that it is good in linearity up to some extent. This platinum is very good in linearity, and it is chemically inertness. And the operating range of its temperature is 100 to 650 degrees Celsius. When I come to the nickel, its operating range is from minus 180 degrees Celsius to 430 degrees Celsius. And copper, it is having minus 200 degrees Celsius to 260 degrees Celsius. But this nickel and copper, they are susceptible to the corrosion and oxidation process in the environment. And tungsten, it is having an operating range of minus 270 degrees to 1100 degrees Celsius. So this was the metals properties here. When compared to the all the four metals, platinum is very good in its linear characteristics. And nickel and copper are somewhat non-linear. When compared to the platinum, these three are somewhat non-linear in their nature. But if we are looking at the particular application like our air conditioning systems, in air conditioning systems, the RTD, which is the temperature sensor which is using, is mostly they are using nickel as their metallic resistance, because it is abundant in nature, and it is also we can say it is very cheap, and nobody is going to see the what is the accurate temperature when you are wearing through your remote in your air conditioning system. Nobody is going to sense it. So at that cases, the benefit, the manufacturer is going to get somewhat a benefit because of these metals. And the basically the construction structure of the RTDs is going to be arranged in a Wheatstone bridge circuit. As I said, signal conditioning analysis is there, so it is going to be arranged in such a format like this, in a Wheatstone bridge format, where this is my RTD I am placing, because these RTDs in general, practically if we are talking, they are connected somewhere near the control rooms, and the machines are set up in some other place. So we have to take some leads here from here, and these leads has to be transformed throughout the channel to the machines. So in between we are going to have a problem of the environment effects or some resistance losses, some heating problems. So generally your Wheatstone bridge, your deflection galvanometer, it is going to sense the sensitivities. So what is happening here, because of these two leads also connected here, so these heat losses are also calibrated here, and it is going to show the deflection more. So here because of these type of structure, you might have seen some lead wire losses may be occurred. So to eliminate those lead wire losses, you can include three wire methodology. You can create one more here, and you can change the little bit circuit complexes, and we can analyze it. Otherwise, four wire method or lead wire methods also we can use, and we can change the structure of this Wheatstone bridge process. That's it from me. Thank you.